So this is the question. Prove that the angle between the two tangents drawn from the external point. Suppose this is the external point P. So two tangents drawn from the external point. Okay, so this is the external point and these are the two tangents. Is supplementary to the angle subtended by the line segment joining the point of contact to the center. So this is the point of contact. Suppose this is the center O. So here this one is the line of contact with the center. Here this is another line of contact with the center. So this angle here it is 90 degree, as you know that the radius is always perpendicular to the tangent. So here we have to prove that the sum of this angle and this angle is equals to 180 degree, or the angle between the tangents drawn from the external point and the angle which is made by the line joining the point of contact to the center. So sum of these two angles we have to prove that it is supplementary, or sum of these two is 180 degree. So let's name this PT and here I've taken it S. Okay, so here given, what is given? PT and PS are tangent from point P. This is given, and here we have to prove, what we have to prove, that angle P plus angle TOS is equals to 180 degree. So here to prove this, what we will do, here this question is very simple. The only problem is with the figure. If we will be able to draw this figure, then the question will be very easy. Now you know that angle OTP and angle OSP both will be 90 degree. You can give the reason. What is the reason for this? That radius is always perpendicular to tangent. Perpendicular to tangents. So this we know. So now we can take in quadrilateral PSOT. Okay, so we can take in this. So we know that sum of all the angles will be how much? So angle P plus O plus angle OTP plus angle PSO will be equals to 360 degree. We know that sum of the angles in a quadrilateral is 360 degree. So this we will get here. So here just simply put the values. So angle P plus, in the place of O we can write TOS, the same thing. So here we will get 90 plus 90 equals to 360. So from here you will get angle P plus angle TOS is equals to 180 degree. Okay, so hence we have proved that our sum of these two angles is supplementary, or sum of these two angles is 180 degrees. So both the angles will be supplementary. So here this is the question. A triangle ABC is drawn to circumscribe a circle. So a circle is there and the triangle is circumscribing the circle with radius 4. So the radius of the circle is given 4 and there are the segments BD and CD. So here the segments BD and CD are there and the length of these are 8 and 6. So you have to find the lengths of AB and AC. So you have to find AB and AC. So now to solve this question, first you can look at the diagram. So here as you can see BD is given 8. So this side will be also 8. Why? Because we know the theorem that the tangents drawn from the exterior points are equal. So same way this will be also 6. Now this is the missing side, so we don't know, so I am taking it X. So here this will be also X. Okay. So now we have to find out this missing side and X, then only we can find out the value of A. Okay. So now to find out this value of X, I'm just joining these. So now here what I will do, here you can see there are 3 triangles. This triangle you have here. Okay, if you have to find out the area of this triangle, so that area can be written as half area of triangle AOB will be how much? Half of O. In the place of O, I am just writing R. You can take this one 4. This is the radius. So radius into, as the radius is perpendicular to the base, and the base will be x plus 8. Okay. So we can do this. Okay. The same way you can take another triangle. So I'm taking another triangle, the other triangle like this triangle I'm taking. So you can find out the area of this triangle as well. So this area of this triangle will be how much? Area of COB will be equals to half of R into, the sides are 6 plus 8. Okay, the base will be 6 plus 8. The same way you can find out the area of the third triangle left, that is AOC. So area of AOC will be how much? Again, half of area of 6 plus x. Okay, so now if I'll add all these areas, so what I'll get? The area of the bigger triangle, that is area of ABC. Okay, now area of ABC we can find out using the Heron's formula, that is S into S minus A, S minus B into S minus C. Okay, now for doing this, first we need S. So S will be A plus B plus C by 2. So here the value of A is, means one of the side is 6 plus 8, the other side is 6 plus x, and the other side is 8 plus x divided by 2. So if you will solve, you will get x, S equals to 14 plus x. So that will be your x. You can just add, so you'll get 2 into 14 plus 2x, so divided by 2 will give you this. So the same way here we can find out the area of the triangle ABC. So that will be, in the place of S I am putting the value of S, that is 14 plus x. Here S is 14 plus x minus the value of A, where the side is 6 plus 8, so I am writing it 14. Here the next side, close it. Here the next side, here we have 14 plus x minus the other side is x plus 6, and then close it. Here 14 plus x, and the other side is x plus 8. So now you can solve it. So here we will get 14 plus x into, here you can see something you can cancel out, like here 14 you can cancel, 14 minus 14. Here then the next one, if you open the bracket, I'll just open the bracket, then it will be easier. So here only x will remain. Here if you open the bracket, you will get 14 plus x minus 6. In the second bracket you will get 14 plus x minus 8. Okay, so now we can cancel out few things, like here x you can cancel, here x also you can cancel, and then we will write the remaining terms. So here we will get root of 14 plus x into x. Here I'll get 14 minus 8, 8. Okay, and the second one I'll get 14 minus 8, 6. So this I will get. So this is my area of triangle ABC. As I told previously, that the area of this triangle ABC will be same as the area of AOB plus area of COB plus area of AOC. So sum of all the small triangles will be equals to this area. So just keeping all these values equal. Okay, so here I'll get 6 8s are 48 into x plus into 14 plus x. This I'll get here. Here I'll just take the areas. As you can see, in all the three, half r is common, so just taking out half r common, then I'll get x plus 8 plus 6 plus 8 and just keeping it 14, and the next one is x plus 6. Okay, so now just we have to simplify here this to get the value of x. So now here in the left side I have root over 48 14 plus x. The right side I have the value of r we have, that is 4 centimeters. I can put it here. So here I'll get 2x plus 14 plus 14, 28. Okay, now just try to simplify it. Okay, so like from this bracket you can take 2 common, so 2 you'll get from here, 2 I'm taking common, so I'll get x plus 14 here. And the right side, this also can be simplified. I just leave it like this. So here we have 48, 14 plus x. Now as you have root here, so we will square both the sides. So squaring both sides will give you 48 into 14 plus x. And here if you square, so you will get 2 into 2 means this will be 2 times, and then here I'll get x plus 14 whole square. Again we can cancel out few things. Try to cancel out the things, otherwise your calculation will become very big. Okay, so 1 x plus 14 I can cancel here. Same way here we have 16, so 16 3 is a 48, so that we know. So here we can write what we will get. I'll get here, that will be 3, and here x is missing, 1x is here, so you will get 3x here, and then here we'll get x plus 14. So this will be 3x minus x will be 14. So from here we'll get 2x equals to 14, or your x will be 7. So we got x equals to 7. Now just look at the figure that we had previously. So x came 7, this is also 7. So now you can find out the value of AB. So AB will be 7 plus 8, 15 centimeters, and your AC will be how much? 7 plus 6, 13 centimeters. So we got both the values.